Hello student, good day. We are going to continue from where we stopped last time. If you can remember, we have discussed what are called synthesis, where we discuss all aspects of them. So today we are going to continue with another closely related dosage form that are called syrups. Syrups, by way of description, they are sweet, viscous, concentrated aqueous solutions of sucrose or other sugars, meaning that they are just a solution, viscous solution. You must remember this, they are viscous and they are sweet. So sucrose in water actually lead to the development of syrups. So we have mainly we have some classes of them, okay? Three main classes. So the first one is called medicated syrup, which usually contain therapeutic or medicinal agents. So by the name therapeutic, you shall expect that they are being used to actually treat certain ailments, certain conditions, okay, due to the constituents of some active ingredients in them in form of medicinal agent. On the other hand, we also have another syrups that are called simple syrup or syrup, just syrup, okay. So these syrups are the ones in which when purified water alone is used in making the solution of sucrose to the preparation. So when only purified water are used actually to dissolve the solute, that is the sucrose, so that particular syrup is called syrup, okay, without any another qualifying word, okay, or simple syrup. So whenever you see in the literature reference to simple syrup or just syrup, sometimes it come with certain another definition. That is the kind of authority which actually describe it. For example, British Pharmacopoeia, United States Pharmacopoeia. So some of this sometimes in the literature you see syrup BP, okay? Or yeah, syrup BP is one of the most popular that actually you will find in many extemporaneous, in many official preparations, okay? So this syrup only contain sugars in form of sucrose and water. So they don't have any other additional constituents other than these two particular agents. So the third group is what we call syrup containing aromatic or flavoring agent, but no medicinal substances. Okay, so that is the third category of syrup. So these ones they contain the sucrose dissolved in water, but in addition they contain another agents, okay, usually aromatic or another flavoring agent, which give them another features in addition to sweetness and viscosity. So that aromatic agents or any other flavoring agent actually will give certain aromatic effect or flavoring characteristics to that particular syrup. And this group of syrups, they are the ones that are called flavoring or flavored syrups. Okay, so that is the three main categories of syrups that we have. Then syrups actually, as expected, they offer a pleasant means of administering disagreeable taste, okay, such as nauseous, saline, or bitter taste drugs. So drugs which such kind of nauseous taste actually they are assisted using syrup in administering them. Okay, so syrup is used as a vehicle to administer such drugs with such particular characteristics. They are also used as vehicle or flavors for extemporaneous preparations. Remember, we have discussed some oral liquid preparation, which include elixirs, which include linctuses, and so on. So we have seen that in the preparation of these particular solutions for oral administration, usually syrups are used as a vehicle in order to actually help in delivering the drug with nauseous, saline, and bitter taste or any other nauseous taste. And in addition to that, they also actually give comfort to the patient when taking them in terms of acceptability. So Syrup are most frequently administered to pediatric patients, and the parent also prepare them because they contain little or no alcohol. They contain little or no alcohol. So unlike elixirs, we have discussed elixirs before. We have seen that some elixirs contain alcohol um, up to 40%, and that's why most of these elixirs with high content of alcohol, they are not suitable for for younger children. Okay, so they are not suitable for children because of the high content of alcohol. So one of the advantages of syrups, mostly they don't contain alcohol. Mostly they don't contain alcohol, but there are little exceptions where some syrups contain some little alcohol. We will get to know that as we move further. Syrups contain drug extract which are liable to decomposition. So a strong solution of sucrose prevent decomposition by exerting direct osmotic pressure and inhibit the development of bacteria, fungi, and molds. So the concentration of syrup when it reaches certain level, actually it inhibits the growth of microorganisms due to the build-up of the osmotic pressure. So that osmotic pressure actually don't people the development of cell wall of bacteria, and that actually is an advantage which will keep the syrup free from those microorganisms. Syrup are good demulcent and soothing agent, and hence they are special valued in cup. Okay, so because of that demulcent and soothing effect, they are heavily employed in the preparations of as cup preparations for both children and adults. So remember taking cup syrup for any reason in the future. Okay, so most of these most of this preparation of cup contain syrup as vehicle. Sucrose is the most commonly used in the preparation of syrups, as I described earlier, but it may be replaced in whole or in part by other sugars such as dextrose and non-sugars such as sorbitol, glycerin, or propylene glycol. So all these substances that I mentioned, sorbitol, glycerin, and propylene glycol, they are what is called glycogenic, meaning they usually get converted in the body system to glucose. They're converted to glucose in the body system. So non-glycogenic substances like methyl cellulose or hydroxymethyl cellulose can also be used for replacing glycogenic material in the preparation of syrups. And this particular agent are usually employed particularly for preparation of syrup for diabetics patient. We know diabetics is actually a condition which actually lead to the high glucose level in the body. So as those particular category of patient, they have to avoid anything that will lead to elevation of their glucose level, including medication like this one, because of syrups, the sugar content of the syrup make it unsuitable for them. So there's a solution for them where methyl cellulose and hydroxymethyl cellulose are used in order to actually prepare suitable syrup for those particular category of patients. Concentration of sucrose in sugar-based syrups is very important. Why? Because a dilute solution of sucrose supports the growth of microorganisms, whereas a saturated solution may lead to crystallization of a part of sucrose under condition of varying temperature. So, if syrup actually contains 65% by weight or more, uh, sugar, so that solution retard the growth of microorganisms. As I said before, one of the good advantages of syrup is their characteristics to inhibit the growth of microorganisms due to the build-up of osmotic pressure. But that actually is only it can only occur if the syrup reach certain percentage. The minimum percentage for that particular properties to be attained is 65%. Is 65%. So any syrup that is below 65%, I mean in terms of content of sugar, that means that syrup has to be supported with appropriate preservatives. Otherwise, there could be chance of growth of microorganisms. Hence, it can easily get contaminated. But syrup that attain the concentration of 65%, actually that particular syrup uh, has the ability to retard the growth of microorganisms. So simple syrup, usually simple syrup BF, which is a simple syrup British Pharmacopoeia, is a syrup which contains 66.7% of sucrose in water. Okay, so it's one of the good syrup that actually had this characteristics of retarding the growth of microorganisms due to the build-up of osmotic pressure in them. Syrup, so the commonly employed preservatives that are used for syrup which contain lesser concentration include methylparaben, benzoic acid, sodium benzoate, and some other suitable preservatives that are acceptable for oral consumption. Flavoring syrup do not contain active ingredient. As I said before, they are not intended to be administered as such, but they are used as a vehicle ingredient for their flavoring and sweetening properties. How are syrup prepared? Syrup can be prepared using various methods. We are going to discuss some of the most relevant methods here. So the first one is called hot process. By the name hot, meaning as I said, there's a involvement of heat. So in this method, um, the active pharmaceutical ingredients has to be neither volatile, and it has to be non-thermolabile, meaning uh, it should not be able to, it should not get deteriorated when it is exposed to high temperature. So thermolabile substances and volatile substances cannot be process using this particular method. That is one thing that you must remember. Then in terms of procedure, desired amount of sucrose is weighed in a third dish. Purified water is added and heated on a water bath till the solution is obtained. Simple, okay? So the appropriate amount of ingredient is measured appropriately, and then it is actually added into the appropriate amount of water, okay, that has been calculated for the preparation, and then a heat is applied. That particular mixture is heated up in appropriate water bath, okay, until the sugar completely get dissolved in the water to form the syrup solution. The product is strained and enough boiling water uh, is added to adjust the desired weight or volume. Okay, so eventually when you have all the syrup dissolved in the water, so another additional hot water are added to adjust the volume to the final volume of the preparation. But care has to be taken to avoid excessive heating, because excessive heating can actually lead to the inversion of sugar, and inverted sugar readily ferment and darken in color, so that has to be avoided. The second method is called percolation method. You can see an image here, okay, of the setup of percolation system. So we use a kind of an apparatus that is called a percolator, whereby that percolator is packed with a cotton wool at the end, at the discharge. Okay. Then in addition to that, we also have a filter medium. You see perforation here. This arrow indicating perforation. Also, it's a appropriate filter medium is added. Some of the perforators even have sand filters. Okay, so above the filter medium, we have actually the drop, the solid rather, or the drop constituent. In some cases, don't mind the crude plan here. This one actually, because most of the population system process that we use involve the extraction of the herbal drugs. So that's why this one, this image is reference. I mean, is a reference to that. But in this case, for the preparation of syrup, so instead of crude drug, sugar, sucrose, sugar or other appropriate. I mean, sucrose or other appropriate sugar is added here. Okay, so it's added here so that it allow the permeation of the menstruum. The menstruum here is water. Okay, so in our own case, for the preparation of syrups, water is our menstruum. So water is added here, and that water will permeate through the sucrose, and then eventually it pass through the dissolved one. Only the dissolved one will actually pass through the filter medium, the perforated place, and they get into the container. Okay, so that is how this process is done. That is the actually the working, or rather the steps involved in this particular process. Sometimes the percolate, meaning whatever is collected here, sometimes is recirculated. It's recirculated back into the menstruum, so that the complete dissolution of syrups of sucrose is obtained. Okay, so eventually the uh, the final volume is obtained by adding more purified water through the coating, so that the retained syrup in the cotton is washed through the content. So that is basically how this particular method uh, is actually, that is how this particular method can be described, uh, uh, that we call population method, cold process. So it does not involve heat unlike the previous one. The next method is what we call addition of medicating or flavoring liquid to syrup. Remember, initially we said that we have three categories of syrup, right? Simple syrup, medicated syrup, and flavoring agent, flavoring syrup, sorry. So the method is useful when fluid extract, tinctures, or liquid are to be added. So in this case, other than the sucrose and water, we add other constituents, either medicinal agent or aromatic or flavoring constituents. So sometimes it can be an extract or tincture. So in this case, actually alcohol is present in this liquid to dissolve resinous or only resinous substances, because some of these aromatic content, they are insoluble in water, so we have to actually use alcohol to dissolve them. In addition to that, assisting in dissolution, alcohol also act as a preservatives. A modification of this process consists of mixing the fluid extract or tincture with water and allowing the mixture to stand uh, to separate out insoluble constituents, filtering and then dissolving sucrose in the filtrate. However, this method actually can be used only if the insoluble constituents are not the active ingredients. So that is all about this. So the next method is what is called agitation without heat. Okay, so this method is suitable for preparing syrup containing heat labile constituents. Okay, so it does not also involve any heat, so meaning that even constituents, even constituents that are thermolabile can be processed using this method. So it involves actually adding sucrose or other ingredient, if any, and purified water by placing the ingredient in a bottle of about twice the volume required for the syrup. Okay, so this is done to allow free space so that agitation can be achieved in the container, where there must be a free space where the mixture can move around up and down so that agitation can be achieved. The bottle is stopped to avoid contamination and loss of water by evaporation and then agitated. For large-scale preparation of syrup by this method, glass-lined tanks with mechanical agitators are usually employed. Okay, so this is about this method and which actually represent the last method we'll discuss here for the preparations of then preservation and storage of syrups. So in terms of storage, syrup should be stored at temperature not exceeding 30 degrees Celsius because they can be actually you remember that we said at excessive temperature they have a tendency to actually get inverted, although little beyond 30 is not that temperature that will lead to inversion, but high temperature of 100 degrees centigrade will lead to that. So but for proper stability of the preparation, it has to be stored at a temperature not exceeding 30 degrees Celsius. Unofficial syrup should be stored in a well-dried, completely peeled, and carefully stropped bottles in a cool, dark place because the stability of some syrups may be adversely affected by light, air, and heat. So it's one of the things that you have to remember when storing the syrups. In terms of label, the label shall state the date of manufacture, date at which this preparation should not be used, meaning the expiry date, and the condition under which the syrup shall be stored, as we have actually stated before, not at the high temperature and so on. And it has to be protected from light, meaning they should be actually stored in a amber colored bottle and not prevented from direct access to light. Example of syrups, we have many of them. The first one is a simple syrup which contain 66.7% of sucrose in water. We also have what are called orange syrup, tolu syrup, raspberry syrup, and blackcurrant syrup. So all these, from the simple syrup to blackcurrant syrup, are example of syrup that are called flavoring agents. They are only used as a vehicle to actually give some flavoring effect to the preparation. But we also have other syrup that include codeine syrup, squalene syrup, and so on, which contain medicinal constituents that are used for therapeutic effects. So the next look at oral preparations that we'll be discussing is what are called aromatic waters. So by description, aromatic waters are clear, saturated aqueous solution of volatile oil or other aromatic or volatile substances. That is one thing that you must remember. They are clear, like elixirs. Elixirs are also clear. So aromatic water has to be also clear, and they are always saturated solution of volatile oil or other aromatic constituents. Their odor and taste are similar to those of drug or volatile substances from which they are derived from. Aromatic water should be free from impurity and foreign odor, meaning so it should not have a kind of a smoke-like smell for acceptability, since they are meant for oral consumption. They are mainly used as flavoring or perfume vehicles. They shall be prepared from raw material of superior quality. In terms of preparations, they are prepared by various methods. And the first one that I'll be discussing is what is called distillation. Distillation, you can remember some of the distillation unit in our laboratories. We have, I think, one distilled water in the lab 221. Okay, it's a bit common because we use distilled water for a lot of preparations in our laboratories. So especially for the pharmaceutical preparation, for all the water that we use in terms of in pharmaceutical preparation in the lab, we use distilled water. Okay, so you can see the setup here. So in this case, we have the setup actually involve what is called still. Okay, this is the still. So this still is a kind of a bottle, and the solvent is added. In this case, water, and then the plant, the actually auridiferous substances which contain the aromatic constituents is added in the water. Okay, in this still, in this particular still. Okay, so it's added, and then it's mixed properly, and then the setup, it is mounted on the other component of the distillation unit, which contain this condenser, and then also the receiver, the receiving plugs. So usually heat is applied to the still using Bunsen burner, but most of the modern distillation unit now we use electronic heaters. So heat is applied on this plant water content, and then evaporation will start at certain temperature, and then the steam will actually pass through the condenser, and then it gets converted into the water containing the aromatic constituents, and then we have the aromatic water in our receiver here. Okay, aromatic water in our receiver. So that is how this method actually is achieved. And in some cases, a double or multiple distillation is done when we are using with crude substances that contain very little aromatic constituents. So to achieve maximum extraction, we have to repeat or circulate the collected aromatic water after distillation back to the still to repeat the same process, so that the whole of the aromatic constituent is actually extracted. So this particular process is called cohibition. Okay, when multiple distillation is done, is called cohibition. The next method in the preparation of aromatic water is what we call dissolution. So dissolution, we have discussed it extensively in the past. So it is considered as simple, fast, and economical as compared to distillation method, because distillation method involve that distillation system, and it comes with a cost, right? So um, usually, the essential oil is shaken with 500 times, about 500 times volume of the prepared water for at least 30 minutes. And when that is done, the mixture is set aside overnight, and then the next day the mixture is filtered. So the filtrate is considered as a saturated solution of aromatic constituents. Okay, so example of this particular, the aromatic water that I prepare by simply mixing the solid and the solvent is called chloroform water, because chloroform water is an example of aromatic water. Alternatively, also in the dissolution method, there's a way of preparing the aromatic water, whereby in this case, or the example was cited using specific quantities or amount of ingredients. So in this case, 2 ml of volatile oil or 2 grams of comminuted aromatic solid with 15 grams of powdered talc, kiselgu, or pulpit filter paper are mixed together. Okay, so either the liquid form or solid form of aromatic constituent is mixed with talc, kiselgu, or pulpit filter paper in the amount of 15 grams. So they mix this are mixed together. When they are mixed together, then an amount of water is added to form a slurry. So this slurry is shaken for about 10 minutes, and then eventually it is filtered out. So more purified water is passed through the filter to make up the volume. In this case, 1000 milliliter. So this agent that I mentioned, talc, Iselgu, and filter paper, they have to be inert. They shouldn't contain any any effects. Okay, they shouldn't actually change the taste or the odor of the aromatic water. So they have to be inert. Usually they are inert in nature, and they serve multiple purpose. One of the most important effects they serve is as they aid in filtration to render the product more clear, and second, they aid in distribution of oil to increase the surface area, which help in facilitation of the dissolutions of the oil in the water. Okay, so relatively also related to this, aromatic water can also be prepared by diluting the respective concentrated waters with 39 times its volume of purified water. Because in aromatic water we have what are called concentrated water. We also have what are called ordinary aromatic water. So sometimes this ordinary aromatic water are prepared from the concentrated water. So in such cases, when the aromatic water are prepared from the concentrated water, so 1 part is to 39 parts of distilled water are used to prepare the aromatic water. So example of concentrated waters include anise waters, caraway water, cinnamon water, still water, peppermint water, while the ordinary aromatic water include camphor waters, chloroform water, peppermint water, strong cross waters. So I'm going to give some specific details about some of these aromatic water that I have just mentioned, so that we know a bit more detail about how they are prepared. So the first one that we'll be discussing is camphor water. This camphor water, it contains ingredients such as camphor, alcohol in 90% strength, and then purified water. So in terms of method of preparation, the camphor is dissolved in alcohol because camphor does not dissolve readily in water. It is sparingly soluble in water. So when this camphor is dissolved in water, it is then added. This solution of camphor in alcohol is added in successive portion of water. Okay, so it's the alcohol solution actually that are actually added to the water. And remember, we have discussed this before. So when that is done, the mixture is shaken until the camphor is dissolved. So in terms of properties, camphor is sparingly soluble in water, as I said before, at 20 degrees, and that's why it is dissolved in alcohol. In terms of solubility in alcohol, it is 1:1 at 20 degrees Celsius, and this will help in fine precipitation of the camphor, which aid in its solubility in water. Official camphor water is a 0.1% weight by volume solution of camphor in water. In terms of storage, it has to be stored in a well-closed container in a cool place, and the dose of 15 to 30 ml is used, and it is used as vehicle and carminative. When we say carminated, they are those ingredients which are actually held in actually soothing or actually relieving flatulence. They help in relieving flatulence. When we say flatulence, we are referring to condition whereby there's a build of gas in the stomach. Okay, so this carminative, or any ingredient that is categorized as carminative, it has the potential of either prevention of building of excessive gas, or it also help in actually expelling the gas that has been built in the stomach. So this camphor water, they have that particular characteristics. The next aromatic water is what we call chloroform water. Chloroform water contain ingredients such as only the concentrated chloroform and then purified water. So in this case, 2.5 to prepare 1 liter of this aromatic water, 2.5 ml of chloroform is actually dispersed into water up to 1 milliliter. Okay, this will give a kind of 1:400 times. Okay, meaning 1 time of concentrated chloroform to 400 times of water. So simply by mixing the 2.5 ml in water, with help of shaking, we have a chloroform water formed. In terms of storage, it has to be protected from light. It has to be stored in a cool, well-closed containers. In a cool place and in a well-closed container. It can be taken in a dose of 15 to 30 ml, and it is used as vehicle and preservatives. Okay, it is used as a vehicle and preservatives. So mainly, it is used as a kind of excipients for liquid oral preparations. The next category is what we call concentrated peppermint water. This contains ingredients such as peppermint oil, alcohol in form of 90% strength, and the purified water. For the preparation of this aromatic water, oil is dissolved in alcohol. We know oil are insoluble in water, right? So, but alcohol helps in actually dissolving them and then disperse them uniformly in the water. So when this, after dissolving the oil in water, this preparation is diluted with water and then shake vigorously. So filter aids such as talc may be added to clarify the mixture. The active ingredients which are present in the peppermint oil include pre-menthol, methyl acetate, and ester. And the preparations of this aromatic water has to be stored in a well-closed container in a cool place because of the volatile nature. And then they can be taken in a dose because you know they are concentrated, right? So you see, you don't expect them to, unlike the other water that can be taken 15 to 30 ml, this one is only 0.3 to 1 ml because of the high concentration of them. They are used as carminative. I have described the carminative before, right? So they are also used as carminative. Concentrated waters like anise waters, caraway water, cinnamon waters, and dill water are also prepared in the same way as this peppermint water that we just described. The next dosage form or liquid preparation that I mean for oral consumption that are taken internally is called spirits. Spirit is not a new word, right? We have spirits for internal use, we have spirits for external use. So spirit or essence consists of alcoholic or hydroalcoholic solution of volatile substances. That is okay. So it's simply alcohol which have some constituents of volatile content in them, okay, and then some little content of water. Usually they contain water also. That's why we say hydroalcoholic solution. So but this content of water is usually small, okay. So brandy and whiskey were the first spirits that come into being, and spirit usually contain high alcohol concentration. For example, chloroform spirit contain 83 to 87% volume by volume of alcohol, okay, which is excessively high when you compare to any other dosage form for oral consumption, okay. So that is why these preparations are not for children, okay. They are strictly for adults. As the aromatic and volatile substances are more soluble in alcohol, spirit can hold a greater concentration of this material in solution than the corresponding aromatic water. Spirits should be stored in tight, light-resistant container and in cool place to minimize the evaporation and volatilization of alcohol or the active principles. Because of the high content of alcohol, which we all know that alcohol is highly volatile, right? So that's why they have to be stored in a cool place to avoid that volatilization, and an airtight container, which they also must be protected from light because of the deterioration possibility of the active constituents in them. As I said before, they are used for both internal and external. So for the internal, they are used for certain therapeutic effects. They can also be used as a flavoring agent. For externals, they are used as rubifications or inhalants or in inhalation purposes. So for the internal consumption, they have to be diluted before use to reduce the pungency of the spirits. In terms of preparations, spirits can be prepared by multiple methods. Four main methods can be used to prepare them. The first one is just by simple dissolution, which we described before. So in this case, the solute, okay, or the active constituent actually is dissolved in excessive alcohol and little water that has a little water in it to prepare the spirit. So chloroform spirit and spirit of ether are example of spirit that are prepared by this method. We also have what we call solution with maceration. We know maceration, right? Maceration, simply you add a drop content into the solvent and allow it to stand for some time, maybe some days, okay, with agitation, I mean not frequent, with occasional agitation. Maybe after some hours you agitate, after some hours you agitate. So that is how this spirit I prepared. Example of this one is peppermint spirits. It's one of the example of this particular spirit. We also have spirit that are prepared by chemical reaction. Example of this is aromatic ammonia spirit USP, which involve a chemical reaction of converting the official ammonium carbonate to true ammonium carbonate to enhance its solubility. Ethyl nitrates, which is used in the preparation of ethyl nitrate spirit, is obtained by the action of sodium nitrate on a mixture of alcohol and sulfuric acid in equal condition. So this is another example. Ethyl nitrate is also another example of spirits that are prepared by chemical reaction. So the last category is distillation, which we have discussed under aromatic water. So it's the same process. So the spirit that are prepared by distillation method include brandy, whiskey, and aromatic spirit of ammonia. So these are some specific, I want to also discuss some specific example of spirits, okay, to discuss how they are prepared, like we did for the aromatic water. So just some more detail about how some example of spirit that I prepare is as follows. The first one is aromatic spirit of ammonia. So this aromatic spirit of ammonia contains ingredients such as ammonium bicarbonate, strong ammonia solution, lemon oil, nutmeg oil, alcohol, and purified water. So simply they are prepared by distillation and kind of a chemical reaction, formation of ammonium carbonate during the process. Okay, and in terms of properties, usually spirit are clear, so it has to be clear. It has ammonical odor, but remember that it may darken on storage, so that care has to be taken. It has to be protected from light. Okay, incompatibilities. In terms of incompatibilities, it is incompatible with acids, sulfuric, calcium, and barium. Okay, so and some alkaloidal salt and some alkaloidal salt. So it is incompatible with these heavy metals. In terms of storage, it has to be stored in a well-closed container and a cool place. For the dosage, very little is taken as a dosage, 1 to 5 ml, and it has to be diluted with water because it is used for oral use. It is used for oral, it is administered internally for oral, for internal use. It is used as stimulant, okay? It stimulates the GIT, and it also used as pharmaceutical aid. When we say pharmaceutical aid, we are referring to being used as excipients. Okay, so excipient can be of various purposes: preservatives, vehicle, flavoring agent, and so on. So it has one of these purposes that we use it in many internal preparations. Another example of spirit is what we call chloroform spirit. It contains 5% volume by volume of chloroform in 90% alcohol, and it has high content of alcohol, 83 to 87%. We prepare it by simple mixing of the chloroform in alcohol, and then in terms of storage, it has to be stored in a closed container and a cool place due to the volatility of alcohol. The dose also is very small because spirit has high content of alcohol, so it shouldn't be take a large amount. When it takes a large amount, we know the effect of alcohol, right? So that's why. To avoid that, is very little amount that is taken. 0.3 to 1 ml is enough to trigger the therapeutic effect. I mean the expected effect of that particular chloroform. So it is used as flavoring agent and preservatives. So the next one is compound orange spirits. It contains ingredients such as orange oil, lemon oil, coriander oil, anise oil, and alcohol. It is prepared by simple mixing, and it contains 86 to 90%, very high content of alcohol, 86 to 90%. So it has to be stored in a cool place and well-closed container. It is also used as excipient, that is pharmaceutical aid. So we also have what are called industrial spirits. Okay, so this industrial spirit mostly they are used for external preparation, methylated spirit. So the composition is it contains 19 volume of alcohol plus 1 volume of wood naphtha. It is clear, volatile liquid, and it has the characteristics of achieving boiling point at 78 degree centigrade. It has to be closed in a tight closed container and away from fire. That is one thing that you must remember, because it is highly inflammable. It is used as solvent and pharmaceutical aid in some preparations. It is highly inflammable, so the label must to contain a caution inflammable, as it can catch fire easily. So that is about the liquid preparation that I will be discussing. Then to finalize this particular lecture is to highlight some evaluation that are being done for oral liquid dosage forms to actually ascertain their quality. So we evaluate them by various parameters. First one is the appearance, which we use our eyes to actually see if there's a foreign substances floating in them. Okay, so you know some of them actually are described as clear. So this one we have to see if they are really clear or contain some foreign matter, because build up of microorganism or some foreign substances can lead to floating of particles. So another thing that has to be ascertained is their original color and odor. It should match the formulation specification, and also test. We have to actually also ensure that the taste of the preparation is original. We use equipment such as artificial tongue to ascertain the taste for the preparation. We also have pH measurement because we know uh, uh, certain medicinal agents, they are unstable in certain pH range. Okay, so we have to actually monitor the pH of the preparation to ensure that the pH, the final pH of the preparation actually does not contradict the specification of pH of the medicinal constituents that is present in that preparation, because if it goes above, or below the normal range, it can lead to deterioration of the ingredients. So we use pH meters to ascertain the pH of that preparation. If the series of actually deviation of pH, we use excipient that are called buffers, right? We use buffers to maintain the pH. We also characterize the oral liquid dosage form we characterize them by ascertaining or assessing their viscosity. Some of them are viscous, some of them are not. Okay, so there's certain level of viscosity that each preparation actually has to attain. So we use appropriate viscometers to actually characterize their viscosity. So this majorly the characterization or evaluation of a liquid oil dosage form are categorized into two major broad categories: physicochemical test and microbiological contamination test. So the physicochemical tests are the ones that I just described, and many other ones which I have not listed here. Okay, so in addition to the ones that I mentioned, another example of physicochemical characterization of the liquid oral dosage form include dissolution, solubility, specific gravity, and so on. Okay, so then the second part is microbiological contamination. We use various antimicrobial study to actually ascertain or to assess the possibility of presence of any bacterial contamination in the preparations. So we also evaluate them by assessing the content of microorganisms in them. Then lastly, we also check the stability on storage. How does the formulation maintain their stability over time period? Okay, so we use two major methods to assess the stability. We use what we call long-term stability testing and also accelerated stability testing. In long-term stability testing, we use normal time. The preparation is kept under appropriate condition of temperature and humidity, and periodically, maybe after some days, then sample is taken out and then analyzed using an analytical equipment such as HPLC, UV, and so on to ascertain to establish the content of the active ingredient, the strength, and some other constituents in them, whether they are present or they have decomposed or into some other things else. So that pharmaceutical analysis that we done, we actually subject the preparations to will give us an indication of how does the storage actually affected the stability of the preparation. So accordingly, based on how they deteriorated over time period, the shelf life and the expiry date of the preparation is established. Then the second one is what we call accelerated stability testing. In this case, the drug is put under stressful condition of high temperature and humidity, and it is stored over short period, unlike the long-term stability that can be stored maybe up to years, maybe some 2 years, 3 years, periodically checking the sample and see how the storage affects their stability. In this case, actually it is achieved within months, okay, within very short period, maximum 3 months. So under this, but the condition that we subject the preparations to is actually stress condition, higher temperature and higher humidity. So we see how these parameters affect their stability and then use appropriate equations to predict the shelf life of those products in a shorter period of time. So this marks the end of this discussion, and I'm going to stop here. And uh, uh, I wish you happy reading and also success in your examination that is coming up shortly. Thank you very much for your attention.